What an ugly board. There's so much up here. It's okay. It's all connected. We're going to make sense of it. We're going to be talking about how you can look at a graph and know the degree, lead coefficient, number of real zeros, all this nonsense. But before we start, we need to talk about the most basic type of graph, our linear function. Now, linear function is a degree of 1, okay? You learned already about degree. We take a look at a linear function. It usually is like y equals 3x plus 2. Well, the x there has the highest exponent of 1. So right off the bat, if I see a single degree, it means it's only going to have one direction. It's going one direction, okay? So my degree is 1. Now, by looking at my lines, I can start to understand what the lead coefficient is. If it's a positive slope, it's going up. Negative slope, it's going down. So I can clearly see this first graph has a positive slope, so it has a positive lead coefficient. Second graph has a negative slope, so it must have a negative lead coefficient. Now, a number of real zeros. Now, it won't make too much sense here because it's like, well, a zero is a solution, is an x-intercept, is a root. Remember all those synonyms? Yeah. It has to cross here, right? That line's going to cross. So obviously it has one real zero. But sometimes a function will have possible zeros, but not as many real zeros. And we'll take a look here. Okay, so if degree 1 is the most basic, degree 2, we see a parabola, meaning it has a quadratic function, something that has the highest degree of 2, like an x squared. Well, notice something. This has one course of direction. Never even changed its course. This has 2 courses of direction. So that means this is a degree 2. We learned that if it opens up, the a value is positive. If it opens down, the a value is negative. So I can clearly see this opens up, it must have a positive lead coefficient. This opens down, it must be a negative lead coefficient. These are some nice things you look at and you know right away. But how about this one? Number of real zeros. Again, zeros, think roots, think solutions, think x-intercepts. That's really what we're talking about here. Does that ever cross? Oh, no, no, no. So this one has no real zeros. However, this one has 2. So we're going to use these principles to help us answer questions about some graphs I'm going to make up. Keep in mind, this was an odd degree. This was an even degree. They have properties that are going to be applied to all odd or to all even functions. Notice one thing about odd functions here. They're going in opposite directions, okay? Or that way. Either way works. An even degree, though, they agree. They go the same direction, okay? They go the same direction. Any kind of even function, they're going to end up having the same end behavior. That's another term you'll be hearing about, okay? So let's get crazy. Let's just draw one real quick, okay? Let's say I give you this one. And it just goes down. Boy, that's ugly. But that's my function, okay? Right away, I have to know if it's even or odd. Well, I want you to look at the end behavior. Are they going in opposite directions or the same direction? These are going in the same direction. So this is even. Okay? Degree. Now, you heard me earlier talk about courses of direction. Every change of direction represents a new degree. Okay? So we have 1, 2, 3, 4, 5, 6. Crazy! I know. But that is the degree of 6. There were 6 changes there. Okay? Now, ignore all the little humps. All the humps, ignore them. Look, if I were to think of this as one big parabola, wouldn't this open down? Yeah, it would. It's opening down. So would that represent a positive or negative lead coefficient? Negative. So this is a negative lead coefficient. Okay, number of real zeros. X-intercepts. 1, 2, 3, 4. Now keep in mind, the total possible x-intercepts or zeros is always the degree. It won't have more than that, but it's possible for it to have up to 6. But this 6th degree function only has 4 real ones. All right, number of min and max, look at the humps. Mins, I got 1, 2 mins. I got 1, 2, 3 maxes. That's how we fill out the information for this. Now we're going to do 3 more pretty quickly, okay? Let's try this one. Keep it simple. Now you might recognize this one actually. This is a very basic cubic function. I kind of gave it away, but here's how I knew it was odd and degree 3, okay? First off, end behaviors going in opposite direction has to be odd. Next, I had 1, 2, 3 courses of direction. So the degree is 3. All right, now think of this if it was just a line. If it was just a consistent line, started up here and went down there. Is that representing a positive or negative slope? Negative. That was my negative sign. Don't judge. So we have a negative lead coefficient. Number of real zeros. I don't even think about the word zeros. I think about x-intercepts. 1, 2, 3. Got it. Number of min. 1. Max. 1. Look at the humps. Okay, 2 more quickly. Let's do this. Are they going in opposite directions or same direction? Opposite. So this one is odd. How many changes of direction? 1, 2, 3, 4, 5. How many real zeros? 1. Crazy. I know. Now, if this was a line, positive slope, positive lead coefficient. Number of max, 1, 2 top humps, 1, 2 bottom humps. Doing all right? Last one, let's take a look. Let's go, oh, let's get crazy. Oh, yes. That almost is like a camel. No, it's not. But today is hump day. Get it? Anyways, so they're going the same direction. Same direction. So it is even. It's opening technically up. Positive lead coefficient. Degree. 1, 2, 3, 4, 5, 6. Number of real zeros. 4. Number of max. 1, 2. Number of min. 1, 2, 3. I know I went fast, but I was trying to teach you the point that once you understand these concepts, it flies, okay? You should be able to get through these very quickly. It's a quick tutorial on degree, lead coefficient, number of min, number of max, number of real zeros, all of it. Enjoy.